Hello, my name is Andrea Olgiati, and I am a senior principal engineer with AWS. Today, we're going to talk about how to do industrial scale ML governance with Amazon SageMaker. At AWS, we believe that a data-driven organization is imperative for the future. Data fuels machine learning, and it's super important to effectively harness all the data that a company has access to. Forrester estimates that data-driven companies are growing at more than 30% annually every year, but many organizations still do not know how to put their data to work. Accenture found that even though companies are creating and storing a lot more data, 68% of the companies say that they're not ready or able to realize tangible value from their data. And that's because only 28% of companies have a data strategy that can harness their data. This is where AWS comes in, and because we can help you in your data journey. At AWS, we think of a modern data strategy along three vectors: modernize your data storage, unify your data assets, and innovate using your data. Only if you do all this will you be able to unlock the value of your data. Organizations running legacy databases on-prem or managing their own databases still need to take care of undifferentiated heavy lifting, provisioning, patching, configuration, backups, etc., etc. AWS can take care of this. If you want to unify your data assets, you want to make sure that everything that you have is available for analysis and enforce data governance. This is super important, and it's going to get even more important in the next few years. And for this, AWS provides the best-in-class purpose-built data lakes and data stores. Finally, you want to extract insights from your data to drive innovation. And for this, you can use AI and ML services, which is one of the most transformational technologies of our generation. We're going to focus on this last part, of course, and we're going to especially focus on the third layer of the picture that you see in front. We're going to focus on SageMaker. It's one of the components of AWS's data strategy. More customers do machine learning at AWS than anywhere else. And I've had the privilege of helping them use our AI and ML services to extract insights from that data and use those insights to drive better business outcomes. This journey gave me the opportunity to help build one of the fastest growing services at AWS history and learn a lot of valuable lessons. And we're going to talk about some of those today. And one of those lessons is that machine learning isn't the future that we need to plan for. It's the present. And so in this talk, I'd like to share some aspects of this journey and how we can help customers make ML work for them at scale, and maybe in ways that are not so intuitive. Machine learning is key to innovation. According to IDC, the global spend in enterprise AI and ML grew from almost zero in 2013 to $50 billion in 2020. Just 7 years. And that growth outstripped cloud computing, which is growing incredibly fast anyway. This investment in ML is happening because it will enable us to address important economic and social issues. And the impact of this investment is seen by more than the more than 100,000 customers who use AWS for machine learning. And as the customer base grows, there is growth in a number of areas. And let's talk about those areas. Data labeling is growing. The need for labels for supervised learning is increasing year after year after year. Right now, AWS is running over 1 million labeling tasks per day. The number of models is also growing. And this is an interesting part. And this is what we're going to focus on in the rest of this talk. A single customer can deploy over 1 million models. This comes with its own challenges that we're going to explore a little in the rest of this talk. Models are getting more and more complex. Some models now have billions of parameters, and they need specialized infrastructure for it. And also, predictions. The number of requests that are being served by these models, once they've been trained and put into production, is growing. 100 billion plus requests a month. To set some context, we want to talk about how this growth needs to be fueled by industrialization. Let me explain what I mean by that. Up until a few years ago, customers had single-digit models. They had one model, 2, 5, 10. Now some customers have millions of models. And the ability for a human to look after a single model, to train it, to deploy, to monitor, to understand it, that ability is no longer there. You can do it with one model, 2, maybe 5, but not with a million. And so we want to bring ML to its industrial phase. Just like the automotive industry, it's a great example. The assembly line industrialized automotive design and manufacturing launched a revolution in transportation. And not so long ago, the software industry went through the same process. It went from a few specialized business applications to becoming everywhere, to becoming ubiquitous. And that happened through automation, through tooling. Things like, for instance, as simple as makefiles, from implementing and standardizing processes, deployment, testing. And all of this allowed the industrialization of software to bring the scale that we know of software today. In the same way ML has to industrialize, and AWS, we have been at the forefront of driving this industrialization. There are 3 components to it. First is an infrastructure that is tailored for ML to get the performance to do machine learning at scale. Second is tools that are specialized for ML so that you can remove the undifferentiated heavy lifting. Tools like IDEs, debuggers, profilers, collaboration tools, project management. Third is in automating operational practices. We call that ML Ops, and we're going to focus on that part today. We're also going to talk about the infrastructure and the ML Ops practices, especially in the way that relates to model deployment at scale. So we're going to focus on one of the areas that we described earlier on. How can a single customer deploy personalized models in the millions and monitor them in a way that allows them to create a personalized experience for their customers? Well, in our view, customers need a deployment and monitoring workflow. We're not going to cover the training part. That's for another talk. But once a customer has trained 1 million models for each one of their customers, how can they deploy them into production? What are the tools that are needed? And what is the flow that this model has to go through? In this slide, we describe how one can deploy models and then collect ground truth about the predictions that were made, generate baselines, and then merge the two. We're going to talk about that in a second. Understand the behavior of the model, view drift, and then through alerts, understand when models need to be retrained and deployed again. So the first step to it is the automation of the model training and deployment workflow. At AWS, in SageMaker, we have focused a lot on the creation of a production-grade repeatable workflow to process data, train, and validate models. We use SageMaker pipelines to schedule and record in a specialized storage system the behavior of all these components. We want to allow our customers to step through each stage to troubleshoot. We want our customers to be able to access data at points in time, as it was last Thursday at 7:22 p.m. We want to be able to allow our customers to access the data sets in a number of formats through a number of execution and query engines, Athena, Glue, SageMaker processing. What I mean by that is our customers need the same level of repeatability that they have in software deployments in ML development. And our feature store, SageMaker Feature Store, is one of the parts of this strategy. We want our customers to be able to go back in time and, just like one can do in software development, replicate the creation of a model as much as possible. Once models have been created and trained, and again, we're not going to focus on that part, we want our customers to be able to just catalog their models. And the concept that we developed and offer to our customers is a model registry. A model registry allows our customers to list, catalog their models from production, manage model versions, associate metadata such as training metrics, understand and manage the approval status of a model. What I mean by that is models now in this view of MLs as software go through a workflow. They go from development to pre-production to deployment to maintenance. And we want our customers to understand where each model is. And we want them to automate the deployment with CI/CD techniques, just like software. And the model registry is the central repository of all the models. So now that you have a million models that you have trained for your customers, how do you put them in production? And our customers have told us that they do not want to stand up a million endpoints for their customers. As a response to that, we invented SageMaker multi-model endpoints. It's a system that allows our customers to stand up one single endpoint and serve a number of models underneath. Customers want to be able to take their trained model, just put it somewhere, tell the endpoint that it's ready to go, and let the endpoint handle all the complexity. And that's what we built. So SageMaker MME handles all the complexity. It allows the deposit of a single model in S3, and through a simple API, it allows customers to inform the endpoint that a new model is available. As you can see on your screen, a single MME endpoint can have multiple models. In this case, it's for Chicago, Houston, Los Angeles, and New York. You could have many more than that. And each model, each request can ask to be served by a particular model: Houston, Chicago, New York, Los Angeles. SageMaker MME handles all the complexity. It runs multiple instances behind a load balancer that can run multiple models. It can load the same model in multiple instances depending on the traffic. It uses sharding to understand where each model should go. Customers can pin models to be held in memory, and its SageMaker model takes care of autoscaling of the entire fleet. This way, a customer can stand up a single endpoint and then say, hey, I want to run N models behind it. And SageMaker will take care of standing up the number of instances that are appropriate for the traffic pattern that is seen. This allows SageMaker customers to create personalized models and just put them in production in a convenient and economical way. Okay, so now that you have an endpoint that has all these models behind it, how do you monitor it? As we said at the beginning, it's no longer possible for a single human to babysit, for lack of a better word, this large number of monitors. Automation is needed. And as a response to that, we created SageMaker Model Monitor. SageMaker Model Monitor is a tool that allows SageMaker customers to essentially monitor and alert on the behavior of an endpoint. It allows to do a number of things. First of all, it allows to detect data and model quality issues. These are general issues that have to do with the overall model. But also, through the addition of SageMaker Clarify, allows customers to understand the details of the model itself. In particular, it allows customers to explain the behavior of a certain model and the reasons why a particular, for instance, prediction was given. We're going to dive into that in a second. SageMaker Model Monitor has a number of built-in quality metrics. It allows to alert on confusion metrics for binary classifications, something similar for multi-class classification, and then if you have a regression, it allows alerting on standard metrics like RMSE. Customers can build their own metrics if they want, but these come out of the box. So one can stand up an endpoint, and for the endpoint, understand whether the model is still giving the right accuracy, the right recall, the right F1 score. Or one can build custom metrics to run in a way that is actually pretty straightforward. SageMaker Money Monitor periodically captures data, it uploads it to S3, and then customers can provide ground truth data and merge it. And there's one ID that is used to match the two records, the prediction and the ground truth. It supports structured data, and essentially it performs this merging, and then it performs the computations that we described in the previous page. And those computations allow the creation of alerts that our customers can react to in ways that make sense for them. Okay, so far we looked at the capabilities that Model Monitor offers to look at a model in general. But through the integration of SageMaker Clarify, it also allows SageMaker customers to look at the details of the model. Let's look at that. SageMaker Clarify is a system for the analysis of bias and explainability at scale. In particular, model explainability is the activity of looking at a particular prediction from an endpoint and being able to run a feature attribution report. That's essentially the ability to look how much each feature contributes to the final prediction of the model. What I mean is the following. For instance, one can say, hey, for this particular prediction, this particular feature contributed to the outcome of the prediction 17%. And we believe that that's a really important tool for our customers to give better explainability to their customers and start moving towards a world in which ML and AI have better transparency. And we're going to talk a little bit about how SageMaker Clarify works. SageMaker Clarify works by standing up a shadow endpoint. So as our customers stand up the multimodal endpoint that we talked about, data can be sent to this production endpoint and the response returned in a timely manner. But also, a shadow endpoint is managed by Clarify, and it allows the running of the kernel shell technology that we talked about earlier on. And in that sense, it does not interfere with the production process. It scales out the analysis, and we invested time and effort in making that faster and performant. And it allows the analysis to be run at intervals so that whilst the traffic to the endpoint is undisturbed, in the background, we can run this analysis. To do that, we had to scale out SageMaker Clarify, and we spent a lot of time and effort in making it more performant and allowing the scale out of this analysis. On your screen, you'll see a link to a paper that we presented that explains how we made Clarify more scalable, and some examples of runtimes that you can expect while running Clarify for your production environment. So I'm going to bring it all together. Once a model has been deployed, we can monitor it. We can collect the ground truth. We can generate the baseline. We can schedule these jobs, which periodically, at given intervals, will tell us whether the model is actually running in the way we expect it to run. And this will be both on general metrics and on specific metrics that come from Clarify. Then we'll be able to view drift monitoring results, generate alerts, and decide whether we need to retrain the model with new data. What it means for our customers is that they can now deploy a number of models and be alerted, the number of models behind a single endpoint, and be alerted when their system is not performing the way they want, either in the generic or in the particular through Clarify. And we believe that this is a really important advancement that we created at SageMaker. And it allows, our customers have told us that it allows them to just automate. And it's one of the steps towards the industrialization of ML. And with that said, I'm going to thank you for your time. Bye-bye.